Hi everyone. Today we are going to discuss coin combinations 1. What this question states is consider a money system consisting of n coins. Each coin has positive integer value. Your task is to calculate the sum of distinct ways you can produce this money sum. So this question, let me copy the test case and I will explain them. And now we will check. So this is the number of the size of the coins. Okay, this is the sum and these are the coins. we our task is to make the number of possible ways using these coins to make the sum 9, and they had given infinite supplies of these coins. So these are the number of possible ways which we can make sum 9 that sums up to 8. So this is the question. So this is just a variation of the previous problem which I discussed in my YouTube channel, that is to make the number of to state whether we can make some given sum using the coins. So in it is the variation of that problem where we have to just return the possible ways. Okay, so it is also a variation of unbounded knapsack problem. Now let us discuss the approach. We will use dynamic programming here. So as it is a variation of the previous problem, just like the same, we will make a dp array from 0 till the target, and we'll pre-compute all the indexes before that so that we can compute the number of possible ways to reach the target. So what I'm saying is, let's suppose it is fifth index, and if we calculate the number of possible ways to reach the fifth index, there is some 5. Using these all values, can we calculate the number of ways which we can reach the sum 6? Yes, obviously. How? If an index is 5 and if a coin has 5, if a coin can reach 5 and a coin can reach 1, it can usually reach 6 as they had given infinite number of coins. So using this we can reach 6, and similarly if we can say the number of possible ways we can reach the number of the sum value 8, using all these values can we reach the number of ways used to calculate the target? It's obviously. So using that idea we can solve this problem. Now let us discuss the code. Okay, it would be 1, and here we have to take and the target, and we will input n and also target. For taking inputs of n and target, we will initialize a array. Let's suppose it's the coins of n, and we'll input and I is equal to 0 till I less than n, I plus plus c in points of I. All the input part is over now. Now the actual coding part starts, or the approach starts here. So in order to calculate the number of possible ways, we have to make a vector ln dp of this target, okay, plus 5, and let me initialize it to 0. And now let's assume the number of ways which we can reach a 0 is 1. Okay, now using these values we have to pre-compute the further indexes or till the target. So we'll run a loop for int I is equal to 0 till it should be less than or equal to target, and I would be plus plus, and we have to iterate through the coin array also. So we'll for auto coin in the coins array, we'll check whether that coin is less than or equal to the index or the value that is iterating on. So what I'm doing is we'll check if a sum is right. If let us suppose there's an currently we are iterating at the index 7, and we'll check whether there is a coin present in the coins array which is less than or equal to 7. If it is not, if a coin is 9, we cannot make the sum 7. So that is what I'm checking for here. Auto coin in coins array, what I'm checking is if I minus coin, if it is greater than or equal to 0, only then we have to calculate. So dp of I would be dp of I minus coin, and we have to take all the modulo, as in the question they have stated to take modulo. So what I'm doing is, so let's suppose let's take a small value. Okay, if there is 1 and 2 and we have to make a sum 4, let's suppose. Okay, I will make a, so there is 0 1 2 3 and 4. So for reaching 0 we cannot reach 0. So for reaching 1, is there any coin in the given array that is equivalent or less than 1? Yes, it is. 1 is there. So we'll increment, we'll assign dp of I, dp of I as dp of I minus coin. Dp of 1 minus 1, that is 0. So we'll increment it by 1. And for 2, so dp of 2 would be 2 minus 1 is 1, and we'll increment to 1, and 2 minus 2 is 1, 2 minus 2 is 0 1, so we'll increment by 2. So for reaching 2 there are two possible ways, so that is 1 plus 1 and also 2. So for reaching 3 there are for 3 minus 1 is 2, 2 plus 3 minus 2 is 1, 2 plus 3, 3 values, 3 ways how 1 plus 1 plus 1, 2 plus 1 and 1 plus 2. For reaching 4, that is 4 minus 1, that is 3, 3 plus 4 minus 2, that is 2, 3 plus 2, 5. So this is how precisely I am doing the coding part. And now we will output dp of target, and simply well, and that's it. Let me check for this itself. 2 and the sum is 4 and 1 and 2. Possible ways of 5. Let's, and another given test case of CSES itself. So that is 3 9 and the output is 8. Okay, let me check for all these indexes and then we'll check, yeah, both are passing. And let me copy and submit it in the CSES website. Submit. Basically I had a glitch in the previous video which I was recording, so I am recording once again. Yeah, accepted. Thank you guys.